In this short video, we're going to discuss the last of our logical properties. It is a property of sets of sentences that are not necessarily presented in the form of arguments. We're talking about a simple collection of sentences in which all members are on a par. There's no division between premises and conclusions. The corresponding property dimension is consistency-inconsistency. So, a set of sentences can be consistent or inconsistent. It is inconsistent if and only if it is impossible for all the sentences in the set to be true at the same time. And it is consistent if and only if it is not inconsistent. That is, if it is possible for all the sentences in the set to be true at the same time. For instance, take the following set of sentences. Either Amy will go to Paris or Bill will go to Omaha, which is A or B. Amy will not go to Paris, not A, and Bill will not go to Omaha, which is not B. Again, there are no premises or conclusions here because this is not an argument. Notice that the sentences in this set cannot possibly be all true. At least one of them has to be false. If the first and the second are true, then the third must be false. If the second and third are true, the first has to be false. And if the first and third are true, then it is the second that must be false. Since they can't all be true at the same time, this means that they form an inconsistent set. This can also be expressed in terms of truth tables. Suppose that we make a single truth table for all the sentences in the set, where each of the members gets a separate column. Then a set of sentences is inconsistent if and only if there is no row in which all the sentences in the set are true. Remember that each row corresponds to one assignment of truth values. So we can think of this definition as saying that a set of sentences is inconsistent if and only if there is no truth value assignment that makes all the sentences in the set true. Let's make a truth table for our previous set. Remember that the set had three members, A or B, not A, and not B. If you look at each row, you can see that in none of them all the sentences of the set come out true. For instance, in the first row, A or B is true, but the other two sentences are false. In the second row, A or B and not B are true, but not A is false, and so on. There are no rows in which all the sentences are true. Thus, the set is inconsistent. The other member of the pair is consistency. A set of sentences is consistent if it is possible for all its members to be true at the same time. When we say at the same time, what we mean is at the same assignment. Remember that a truth value assignment corresponds to a row of a truth table. So in those terms, a set of sentences is consistent if and only if there is at least one row in which all of its member sentences are true. For example, take this set. To show that the set is consistent, we make a truth table for the whole set. The first row does not show consistency. Not B is false there, hence not all of the sentences are true in that assignment. However, the second row does make all four sentences true. We can stop here because we have shown that there is at least one assignment in which all of the sentences are true. The assignment is A true, B false, as exemplified by the second row of the truth table. Here we see another case of symmetry. Showing inconsistency requires inspecting all possibilities, whereas showing consistency requires only one example. Okay, this is all. I told you this video was going to be short. Bye.